How's it going today? Welcome back to Freeburg's Free Advice. We're going to take a look at some math today, and specifically, we're going to factor quadratics. Let's take a look at anything really in the form ax squared plus bx plus c. And we'll start with something a little bit simple to begin with. Many of us actually might be comfortable with something like number 1. We're like, oh hey, I want to find something that's going to multiply to 6 but add to 5. And so as we take a look at that, we see that, well, I know that if I do 3 times 2, I'll get 6. And I see that 3 plus 2 equals 5. So this should be able to factor like that. Some of you may have even been taught like guess and check, or maybe that's the only thing that kind of stuck to your mind. Well, we can always double check our answers, right? So if we do our distributive property here twice, we can see that we end up with an x squared plus 3x plus 2x plus 6. And then we can combine our like terms there in the middle, and we see that we get back to x squared plus 5x plus our 6. So, good, we factored this correctly. Well, we'll take a look at something that might get a little bit more difficult for us. But let's see something like number 2. Here, again, we'd be like, oh, well, I want to multiply to a negative 6, so I know that one has to be positive, one has to be negative, and add to a positive 1. So what if I did something like x plus 3, but then I had x minus 2? So again, now it's going to multiply to that negative 6, but still be able to add to this positive 1. And so we'll take a look at that. Again, if we do our distributive property to check, we can see that. Well, what if I started to see something a little bit more complicated? That lead coefficient now is something besides a 1. Okay? Well, it gets a little bit more complicated. So we're going to start with something that we already know and walk through the more complicated process. Well, if we take something with the lead coefficient of 1 and a c value of negative 6, we can go find what I'm going to call our AC. Okay? Basically, it's your A times your C. And so when I do this, this is going to be our positive 1, that's our A value, times our negative 6. And so now I have this AC value that equals negative 6. Okay? And then what I want to do is split this into the different factors. We can have 6 times 1, we can have 3 times 2. I know that one of them's positive, one of them's negative, so we're going to actually look for the difference. So 6 minus 1 would give us 5, 3 minus 2 would give us 1, and this column really becomes what our B value is. And so in this particular case, what we're looking for is a positive 1, and so this is what we're looking for. Well, if I want to rewrite my original equation, we can now write this as x squared plus 3x minus 2x minus 6. So really all we did here was we just took that 1x and split it into the factors that we found over there. What this is going to allow us to do is factor left and right sides of what I'm going to call kind of an imaginary wall. Okay, so on this side we're going to be able to pull out a common factor of x, and you're left with an x plus 3. Okay. On the other side here, we can pull out a negative 2, and you're going to be left with an x plus 3. You know you've done this correct when these two actually match up, because now what happens is you have 2 new terms, and that's your common factor. So we can factor out an x plus 3 from both, and what we're left with is this stuff out in front. So we have this positive x and a negative 2. So our second factor now becomes x minus 2, which we saw earlier, those match. So that's good news. This process, even though it takes much longer, is going to work for any type of a quadratic force. So let's go ahead and use this same approach for something more complicated like number 3 here. So again, here's my A value, here's my C value. I can go ahead and find my AC value as 2 times 3, which gives us a positive 6. I'm going to find its factors. In this case, we can do 6 and 1 again, or 3 and 2, just like we saw earlier. But because it's a positive value, either both are positive or both could be negative. In either direction, we're going to add these values together, so we can see that this becomes either a 7 or a 5. And so I want it to be a negative value because my B term here is a negative 5. So I'm looking for a negative 5, so both values will be negative. So let's go ahead and split that up. And so when we rewrite our equation, we see we have 2x squared minus, I'm going to put the 2x here, and minus 3x plus 3. Sometimes it doesn't matter, but if it's very visible, that easy to factor, I like to kind of put them in order that way. Again, here's my kind of imaginary wall that I'm going to factor. On this side, you've got a common 2x. You're going to be left with an x minus 1. On the other side, you've got that negative 3, and you're going to be left with an x minus 1. And so we know we've done it right, again, because this is going to match. So that's good news for us. And so we're left with the factors x minus 1 and 2x minus 3. And now we're fully factored. So there's our final answer. Okay, so hopefully that step from number 2 to number 3 helps you kind of see how these all piece together. I'm going to go a little bit more complicated on you, and we're going to do something like number 4. Because number 3, maybe you can still get lucky, do some guess and check. But 4 is going to take you a lot of guessing and checking to actually make this match up. So let's take a look at number 4. There's my A value. There's my C value. So let's start with our AC, which in this case is going to be 6 times a negative 20. Okay. So 6 times negative 20 is going to give me negative 120. Okay. Well, I'm going to have a bunch of different factors here, and we could be factoring that out for a while. But I know ultimately I want to get to a positive 7. And so with that positive 7, keeping in mind that maybe I want something like, 40 and 3. Well, 40 and 3, that's not going to work because I want the difference of them since it's a negative value. That gets me to a 37, so I'm still way off. I need these two values to be much, much closer together. So maybe we think about something like, maybe even 20 and 6, since we know that one kind of works. And the difference there would be 14. So we're getting closer. Well, maybe 15 works. So let's try 15, and what value is going to get us there? 15 and 8. Yeah, 15 and 8. And that's going to give us 7. Excuse me. So yay, perfect. We found our piece. So we don't need to find every single one. We just need to keep working until we find a way to split this thing apart. And so let's go ahead and split this 7x up into 15x and a negative 8x now. So you've got your 6x, oh sorry, I should have squared there the whole time. So we've got our 6x squared plus our 15x minus our 8x minus our 20. And then again, we're going to look at this kind of imaginary wall there, factor the left and right sides. So up front, we've got a 3 that's common and an x, so let's pull out 3x. You're going to be left with 2x plus 5. Okay, and that second grouping, real quick, let me make a little bit extra room here. So with that second grouping, we see that we can pull out a negative 4. And we see that's left is a positive 2x and a positive 5. Yay, those match up. That's good news, right? So we see that that matches with that, so we're in good shape. There's one of my factors, the 2x plus 5, and then we have the stuff that's left over, which is our 3x minus 4. And now we're fully factored and we're in great shape. Okay? So, factoring, yes, pretty difficult thing. Simple stuff with a coefficient where your a value is 1. You can just kind of do a little guess and check or do that, what multiplies to your c term and adds to b. But once you start getting into coefficients of something other than 1, so when a value is something different than 1, you definitely want to take a look at how to factor this completely all the way through. So, good luck with that. If you have questions, comments, please post, and I'd be more than happy to help you. Hope you've enjoyed Freeburg's Free Advice. Have a great day.